Yeah, NH4 is a bubblegum man. H3O is hydronium. And both of them, man, have a positive charge. The test is coming soon, so know who they are. What about cyanide? That's cyanide. What about hydroxide? That's H. And both of them are negatively charged. Once again, just know who they are.
Nice. Nice. Little polyatomic ion wrap.
Polyatomic ion wrap, check that out. Alrighty, so test hint number 1, this is chapter 9, formulas and nomenclature for regular chemistry. And our first test hint says how to name monatomic anions. You should know that mono means one, and atomic is atomic, and anions are negative. And we have some examples of both polyatomic and monatomic ions here that we're going to be referring to throughout this video. And Mr. Sostin, what is the overall difference that you see between these monatomic ions and these polyatomic ions?
Well, polyatomics have more than one element in them.
Mm-hmm.
You know, the charges can vary, just the same as in monatomics. But in the polyatomics, you have the formulas are much more complicated. And because they have more complicated formulas, they have more complicated names.
Right.
With the ionic or the monatomic ions, they are named very, very simply.
Right. We just go with the metals. The positive ones are named just what the metal name is.
Right.
And the non-metals, we start writing their name and we change the ending to IDE. You've had lots and lots of practice on this, but we thought we'd just touch on the obvious here as we get started because we'll be referring back to that later. Okay, takes us to test hint number 2.
Number 2, how to name and write the correct formula for specific monatomic cations and anions. And then question 5 is actually going to ask you about polyatomics as well. But you're going to be provided a set of answer choices. And it will be the element's name, the formula for the ion produced when that particular element forms an ion, and then the name of that ion. And you have to choose the right one. Is this correct?
Well, I don't know. Iron is Fe.
Sure.
I mean, a lot of people think it's IR, that's iridium. Iron is Fe, and we know it can be 2+ or even 3+, but I really don't know about this ironate name. I don't think I've ever heard of ironate.
Me neither.
Unless it's in the movies or something, so I don't think this part is right. I would not choose this as a correct answer.
You want to find the one that's the correct set. And for those super speedsters, or students who think they're super speedsters, you need to read each part of the set.
Yeah.
Heads
Just
up.
make sure you look at the whole thing and figure out the correct answer.
Number
All right, test hint number 3. How to write the stock system name when given the classical, the us-ic name of a cation. Huh? Well, here's an example. Let's go back to this iron. This iron plus 2 is really, it's not this, not ironate. It is really the ferrous ion. And it's ferrous instead of ferric because it's +2 instead of +3.
Right.
Okay, so it's at the lower oxidation state. Now, how would we name that in the stock system? What? Well, you've been doing a lot of this. You've been writing them over and over and over again. You might not remember that it's called officially the stock system. But in the stock system, we're going to change that ending that represents the lower oxidation state of iron to the actual Roman numeral showing what that charge is. And we started the chapter by having you just go to Roman numerals right from the get-go, and we added in this other like old-fashioned naming system as we went along.
Number 4. Number 4 says how to identify a cation from a list of ion names.
Well, cations are positive.
Positive,
right.
And there are multiple ways of
writing,
of illustrating the name or formula for a cation, and you need to be able to identify them. You need to be able to look at iron 2 and know, hey, that's a metal, it's an electron loser, it's a cation. Ferrous refers to iron. There's a metal. It's an electron loser. It's cation.
Right, and something that would be incorrect, kind of hearkening back here to our ironate, if we had written it as ferrate ion, that would be incorrect because we see ATE endings on the anions, not cations. All right, test hint number 5. How to write the names and formulas of several polyatomic ions. Well, if you look at the bottom of your test hints, you'll see that the polyatomic ions that we have listed here, you're going to need to do something with. You should know these. You should know a lot of them. You should be able to figure out a lot of them from the innie and outie pattern that we showed you on the periodic table. You should have several of them memorized just because you've been doing these over and over and over again on the Monster and Labs and so on. But this is another question, like we said before, where you're going to have the name and the formula, and you need to make sure that they match. So,
Read carefully.
read carefully. If I can point over your shoulder there, Mr. Seston. If we called OH minus the hydroxate ion, or something like that,
Right.
that would not be correct. But if it said OH minus hydroxide, that would be a correct answer choice. So make sure the name and the ion match.
And we are devious enough to
Oh yeah.
give you the proper name
Right.
and formula, but switch the charge. So read carefully.
We did that on a checkpoint. Yeah.
Okay.
Number 6.
6 is what the ate and ite endings of a compound indicate. This goes back to a little bit of vocabulary.
Okay.
Oxy, anions end in ate and ite, and those suffixes refer to the number of oxygens that are present. The ate form of an oxyanion always has one more oxygen than the ite form of that similar oxyanion. You have nitrate, nitrite, sulfate, sulfite, phosphate, phosphite, and so on.
And it's changing the oxidation number of the nonmetal that's not oxygen. And the ending just shows us that there's that difference. Number 7, test hint number 7, how to write chemical formulas for binary ionic compounds. Bi, of course, means 2, and so they would have 2 naries in them. And we always start with the cation first and the anion second, and we've done this over and over and over and over again. You look at any ionic compound, it goes back to even the Leo and Gurr, the oxidation reduction stuff that we did. Positive one first, negative one second.
Always, always.
Okay. Number 8.
Number 8, how to identify an ionic formula from a list. We've been over this 100 times on the front of the Monster. Go through and identify all the ionic compounds. Always have a metal first. There's an exception, but
Here or there.
metal, non-metal,
Ionic compound.
ionic compound.
And a wrong answer choice might be something like carbon tetrachloride here, which must be covalently bonded because it's all nonmetals.
Right.
Alrighty, number 9, test hint number 9. How to write a formula for a binary ionic compound when given specific cations and anions. So this is another one similar to the format for number 2 and number 5, where we will tell you the positive ion, the negative ion, and we'll have a formula written there. And you'll need to make sure that you're crisscrossing using your ion charge method and writing the correct formula from that. So, Mr. Seston, if we have calcium with a +2 charge and chlorine with a -1 charge, we would certainly hope that our students are not just going to say CaCl, right?
Right. Although this choice is going to be there for you,
Right.
highly likely,
So what do they need to do to this?
you need to do that cave painting is what I call it.
Cave
This is just very primitive way of canceling out these charges is move that 2, move that 1, and the formula you're looking for is calcium chloride that has 1 calcium and 2 chlorides.
Okay. And again, make sure that the ions that are given match the chemical formula that is written, because you'll have some that are incorrect.
Right.
Number 10.
Number 10, how to identify a compound that contains a specific cation. If you're given the stock system name. Stock system, remember, is the Roman numeral.
Yes, sometimes we call those the Norman luminals.
The Norman numerals.
And let me show you a couple of examples of what this might look like. So say we had FeO, FeCl4, Fe2O, or Fe2S. Wow, that's horrible. So which ones of these maybe, has iron in the +2 oxidation state?
Which one contains iron 2 ions?
Okay, so we got to think about, well, what's it attached to? Because we know when we see iron, oh, there's several oxidation states that are possible, +2, +3, and I think there's even a +6. So then we got to base this off of the other element. So we've been over oxygen, I don't know how many bazillion times. Oxygen's got a -2 charge. If there's one of them attached to one iron, that means iron must be a +2 charge. So that would solve that one there. Here, if we're attached to 4 chlorines, then iron supposedly is in the +4 oxidation state. That can't be right. Here, oxygen -2, but 2 irons, so each of them must be
+1.
+1, and then here, basically the same
situation.
thing.
Right.
So you have some examples of what incorrect answer choices would look like and how you go about figuring that out, as well as what a correct answer choice would look like. And it goes back to your redox.